Everyone, welcome back to my channel. Hope everyone is doing great in their life. So today we'll be solving problem 778, swim in a rising water. Okay, I will just briefly tell you what does the problem statement states. Okay, so we have been given a grid of size n by m, and each cell in the grid is at a elevation which is present. The number which is present in the cell will tell us the elevation of the particular cell. Okay, so 0 means this cell is at elevation of 0, 1 means which is at elevation of 1, elevation of 2, elevation of 3. Okay, and at any given time t, all the cells whose elevation is less than or equal to the time t will be submerged. Okay, so there is a continuous rainfall which is happening. Okay, so all the cells which are less than or equal to time t will be submerged till that particular point of time. Okay, so let's say if the time t is equal to 1, so till the time t1 there is a continuous rainfall, and the cell 0, this cell and this cell both will be submerged. Okay, if we wait till time t equal to 2, all these three cells will be submerged. If we wait till time t3, then all the cells will be submerged. Okay, now the problem statement says you have to start from this index and reach to the last index. Okay, which is n minus 1 comma n minus 1. Okay, so you will start at this index and you have to reach over here. Okay, but if you at t equal to 0, this is at elevation 0 and this is at elevation 1, you cannot go from one cell to another cell. Okay, if both the cells have the same elevation, okay, then only you can go. Okay, so we have to wait till one particular point of time, where um, till that particular point of time there is a continuous rain, and then there will be a unique path which will be generated, where there will be a certain path where the elevation of all the cells will be equal and you will be able to reach from 0 till 3. Okay, let's take this example. Okay, if you wait till time t equal to 16, so these cells, okay, these cells will basically submerge. Okay, and rest other cells have the elevation which is greater than t, so these cells will not be submerged. Okay, so if you wait till time t equal to 16, all these cells will be submerged and this path will be generated for you, so you can start from here and you can reach over here. Okay, so the idea, the question is to identify a minimum time t till which you have to wait so that you can reach from this index to this index. Okay, so if you closely observe the problem, okay, the idea is to find the minimum path. Okay, it's more or like a Dexter algorithm which comes into my mind by seeing this particular picture. Okay, if you see in this particular path, the maximum elevation is at 16. Okay, that means you have to wait till time t equal to 16. Okay, in order to go in this particular path. If you choose any another path other than this, let's say we have chosen this particular path. Okay, so this path has a maximum elevation of time t, maximum elevation of 24. That means you have to wait till 24 t equal to 24 in order to go through this path. Okay, so in regular Dexter algorithm, we basically, what does when we use Dexter algorithm in order to find the shortest path between two nodes, right? Where two nodes are connected with the weight of w. Okay, here from any cell you can go into four directions. Okay, either you can go up, left, right, or down, and the weight between these two cells is basically the maximum elevation. Okay, in order to go from here to here, you have to wait till time t equal to 23, then only you can go. So you can say that the weight between these two nodes is basically the maximum elevation of these two cells. Okay, this way the cells were connected to each other. Okay, you can imagine a graph where this is connected to this cell with the edge of 1, this is connected to this cell with the edge of 2, and so on and so forth. Okay, now the problem statement is to find the shortest path. Okay, in order to reach from here to here. Okay, so I have basically implemented. I don't want to write the code straight away. Today I'm feeling a bit lazy, so I have written the code, and so what I've created is I created a class called node, and which represents the cell which I'm standing at, and what is the distance, what is the cost that have incurred, what is the time that have incurred in order to reach this particular cell. Okay, so x, y, the positions, and followed by the distance. Okay, distance, or you can call it as cost or time, whatever it is. Okay, now I just define few parameters over here. One is rows, columns, and the grade, and the delta. Delta is basically, this will help me to navigate in all the four directions. Okay, so you will see as we go through the code. Okay, so I just populated all the parameters with the class fields. So I will just map the grid, the number of rows we have and the number of columns we have. And I have also defined a, this is standard, pretty standard Dexter algorithm using cube, which is via BFF. Okay, BFS, breadth first search, sorry. So here I have maintained a visited array, which is of, which is boolean, visited boolean array, which is of size equal to the grid, which will help me to not process the same nodes which were already processed. And then I used a priority queue. The reason in the Dexter algorithm we use priority queue, the reason being we always want to find the optimal path, right? We want the shortest path. Okay, so this priority queue is basically will help me to get the node which is nearer to me. Okay, so here I have basically if you see this comparator, so here I am basically retrieving the elements which are nearer to me. Okay, and so I will be starting from this node, right? So I have this I just defined the start node as 0 comma 0, which is the position, and the cost to reach till here is basically the cost of this grid, right? So, and I've also defined a parameter called max, which will help me to keep track of what is the maximum distance, what is the maximum time or maximum distance in this path so far. Okay, and yeah, so I just push this the initial element into the priority queue, and I will basically loop this, run this algorithm as long as my priority queue is not empty, or once I reach my end. Okay, okay, so I can basically break here. Yep, so yeah, I will start at this node, and I pushed into my priority queue. I will take the first element in from the priority queue, and I will basically see all the neighbors of this particular element. Let's say I am at this particular element. Okay, let's assume that we have already processed it. I am at this particular element, I can go all these four direction, right? So that is what I am doing here. Okay, I'm just getting, this is delta x and delta y. If you see this delta is basically the directions in which I can go. So if I go to the right, then I will, my x will be increased by 1 and my y will remain same. So that's the reason x is 1 and y is 0. If I go to my left, my x will decrease and my y will remain same, so that is minus 1 0. If I go to the top, my x will remain same, whereas my y will increase, so 0 comma 1 and 0 comma minus 1. So this will help me to navigate in all the four directions. So the new coordinates, new ny and new nx, are basically the current coordinate plus the delta x, which I have defined over here. So if there is a possibility that we might also reach out of this matrix, so we have to make sure that we reside in the matrix itself, and we should only process the nodes which were not visited so far. Okay, so that's why I've kept this condition, that these four set of conditions will help me to stay within the matrix, and this will help me to make sure that I'm only processing the nodes which are not processed. Okay, so then the new neighbor is something this nx ny, and if, as I mentioned, the idea is to identify the maximum maximum elevation in a particular path. So in order to, in the regular Dexter algorithm, we update the distance by summing up the distance. Okay, here we don't have to sum up all the elevations, rather than we will update our distance with the maximum which we have incurred so far. So that is what I have done here. And then once I got my neighbor, and then I'm again pushing back into my priority queue. This way I will basically process the elements which are nearer to me at each and every step. Okay, there will be a moment where I will basically reach my end grid. So then I don't have to do further process. I am pretty much sure that I will be reaching here with a minimal cost or minimal time. So I'm just updating my max with this, and then I'm just returning it. Let's try to run this algorithm. Hope this should work. Yeah, it's working. And then I've also submitted this problem. So yeah, the algorithm is working great. No, so this is one approach. Basically there is also one more approach which i I have figured it out later point of time, which is basically the question says to identify the minimum time, right? Not just the minimum, yeah, minimum time. Okay, so if you notice that, if you see at the constraints, each element in the grid can be in the range of 0 to n square. So we know that in order to reach from start cell to the end cell, okay, my time range, I have to wait between a time of 0 to n square. I can, okay, if I wait, maximum I have to wait is n square, this way, so all the cells will be filled. Okay, and the minimum time is basically 0. If all the cells are having this elevation of 0, then I have to wait. I don't have to wait, I can straight away take this particular path or any path basically, which will result me to the same time. Okay, if all the cells were filled with n square, then I have to n square, or if all the cells were filled with n square, then I have to wait a time of n square, right? So it's more or like we have to apply a binary search on the time in order to get the optimal time. Okay, so how did I apply the binary search? Okay, so if you see here, let me just take this and keep it over here. Yep, so my node will again remain the same. Okay, and the only thing is to identify the range in which I want to apply my binary search. Okay, so we are pretty much sure that I will start from this particular matrix, this particular cell. That means I have to minimum, at least I have to wait this much time in order to start. Okay, so my left is basically this grid, and my right is basically, I just kept it as 0, but the maximum time I have to wait is basically, if you see in this cell, the maximum time I can wait is basically the cell, the path which has the maximum value in the entire grid. Okay, I can, if I wait 24 seconds, let's say, that is the maximum time I can wait. It doesn't make sense to wait more than 24 seconds. Okay, so that's the reason the right would be the maximum of this entire grid. Okay, so I have to basically do a binary search on this particular range and identify the optimal time. Okay, the minimum time in order to reach my end. Okay, so if you see here, mid is basically the left plus right divided by 2, and I have to write a condition which will tell me whether I should take left or I should go right, right? So if let's say I have identified a mid which is actually, so what is this mid? This mid is basically the time that minimum, the mid is the time that I have to spend in order to start my journey. Okay, so let's assume that I have a mid value. Okay, so the next step is to identify a path, okay, where all the nodes in that path, okay, where all the elevations in that path are less than or equal to that particular value. Okay, so I need to find at least one path whose elevations in the particular path are less than that particular mid value. Okay, so that is what I have written here. Okay, if you are able to find such path, that means all the elevations which are greater than mid are also achievable in that in the given path. So I should actually search for a lesser path, right? So I will shrink my space till the mid. Okay, so I'm updating my right equal to mid. So right is my potential solution, but still I want to find an elevation or a mid value which is still lesser than the current mid value. So that's the reason I've updated my right to mid. If that is not the case, that means I could not find a path where the elevations are equal to the mid, then I should actually search for a higher elevation. So that's the reason I've updated left to this. Okay, so there will be a point. Let's look at the good function. Okay, so it's just a normal BFS where I will be starting at this particular node and I will be traversing in all the four directions. Okay, and the only extra condition would be this thing. Okay, if 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 a particular path, if a particular edge, okay, if the elevation is greater than the time which we are looking at, that means we don't have to process that path at all. Okay, we should only process the path which has the elevation which is less than or equal to this particular time. Okay, if you found any such path which is greater than, if we found any edge which is greater than the max time, then we should not process it further. Okay, we'll stop it, we'll skip that values and we'll process the other things. Okay, so that is what this basic a good function will look like. You can go through it. I will be posting this code in the comment section. Okay, so the main logic resides over here. Okay, so there will be a moment where either my left will exceed right or my right will exceed left. Okay, so if my right is exceeding left, okay, then my left is actually, if my right is exceeding left, that means my mid is already a potential solution though, so I will straight away return it. If my left is actually exceeding right, that means I did not find any potential solution so far. So that's the reason I've added one extra check over here. If my left is still a good is good, then only I will return my left. Okay, let's try to submit this solution. Yeah, my basic test cases were passed, and let's try to submit this as well. This will also pass because I've already tested it before. Yeah, so if you see my solution, both the solutions were pretty effective in terms of both time complexity and the memory. Okay, yeah, that's all about this problem. Do subscribe to my channel for more such coding videos. Thank you.